cái này nếu tôi về nếu tôi về nếu tôi này thì tôi về đây tôi có sắp rồi nhớ sắp rồi người nhiều dùng sao phải phản kháng Son the tattoo.
The percentage is that higher or not? Okay, so from example, 100 are overweight. Okay? In 2010, for the number of samples which is equals to 750, okay, the sample proportion indicate 130 over 750, okay, are overweight. So they tell you to use the alpha level of significance. You need to use 0.05. Okay? Test what? Is that pi 1 greater than pi 2? Pi 1 indicate what? 2020. Pi 2 indicate 2010. Understand? This is the objective. Understand? Okay, so based on this objective, first step, form the hypothesis. We know our objective we have to prove. It is pi 1 is greater than pi 2. So we have to rewrite it in this one. Pi 1 minus pi 2 more than what? More than 0. Hence, how you form the null hypothesis? Pi 1 minus pi 2 is equals to 0. Okay, with this we get the terms for this part already. So, step number 2, form, you have to use the formula. Okay? So, form the formula P1 minus P2, okay, minus, okay, so sum of the equation that we write in this format, pi 1 minus pi 2, or sometimes you can see the equation that will give you in this one, pi 0. Okay, so this is the reason. Okay, so in this case it is equals to 0. Okay, divided by square root of, we have 1 terms here, pp, we need to find what is this, 1 minus p, then divided by 1 over n1 plus 1 over n. Okay, what is pp? Okay, the formula is x1 plus x2 divided by n1 plus n2. Okay, so this is 160 plus 130 divided by 700 plus 750. So you get this as 0.2. 0.95. Hence, this is 0.05. Here, at 0.95. Okay. Anyone can find out what is the critical value to give you the probability 0.95. Do you remember this value? 1.645. Yeah. Right now. Okay? So remember this value 1.645. Okay, so you just have the critical value. Okay, now the Z test is 2.62. Means that we already know that the Z test is fall in the rejection zone. So we have to make the decision. We reject what? We reject null hypothesis. Okay? If you reject null hypothesis, so the last step, conclusion. We reject null hypothesis. So we write the alternative hypothesis. Pi 1 minus pi 2, okay, is more than 0. In this case, means we have enough evidence to show that the probability, okay, of the men who are overweight in 2020 is higher than 2010. Okay, so we have enough evidence to prove it. Okay, so this is the solution for question 2. Okay, so let's move to question 3 now. Okay, 2 letter. How about 3? Okay, so 3. Okay, so based on the question, you must tell me that this is which category is the log variance, means or proportion, and then it's involved 1 population or 2 population. Then from here you know which equation need to be. Okay, so you see, they tell you about oxide layer, okay, on certain mixture. Okay, there are 2 different mixture, means that right here, this is, we have 2 populations. Okay, they want to determine if one is similar to the other in terms of variability. Okay, again, variability means what? Variance. So what is this? This involves 2 population variance. So you have to use ratio of 2 variance. So you have to use that test. That is how you define which equation. Okay. So of course others are provide the information. They have 2 mixture, and then they use the standard deviation they provide you, and then what is the information from here? Can we conclude that they assist similarity in terms of variability at the significant level alpha, which is equals to 0.05. Okay, so let's see the solution. chosen to be 26 sample, and then they find out that sample mean is equals to 1.85. From this sample, they are using the same sample, which is equals to 26, and they find out that the standard deviation of this mixture is 2.02. Okay? Then our objective for this study is at alpha, which is equals to 0.05. They want to test if the variance is same or not, question mark. Okay? So with this, okay, so you know that this is the hypothesis statement that we need to form. Okay? The first one, okay, they are the same. And the second one, alternative, same or not, they are not the same. As simple as that. Okay, so for the test statistic, which test we need to use? F. Okay, F test. What is F test?
Degree.
Fair enough. So, but do you remember how you choose the S? We choose the sample variance which has the higher value. Okay? From here. Okay, this is the general equation, remember. S1 squared divided by S2 squared. Okay, but you must remember S1 has to be greater than S2. Okay, S1 always greater than S2. This is how it's applied. Understand? Okay, so back to here. So to apply this to our solution here, so we have to choose S2 over S1, right now? Right now? Okay? So in this case, so it will equals to 2.02 squared divided by 1.85 squared. So what do you get?
1.19.
Okay, you will get 1.19. Right now. Okay, so after that, we must get the critical value. For the F test, it is looked like this. Okay, based on the alternative, we need to consider not equal. Not equal means that we must have two critical values. Okay, for here, we have to use f alpha divided by 2. Right now? Okay, so I follow this since I use 2 as S2 first. Okay, so this one is 26 minus 1. Degree of freedom 26 minus 1 because both are the same. Okay, so from the F test, could you find 0.025, 25, and 25? Could you find this value from the appendix? Okay? F, the nearest, sometimes you cannot get the exact value.
F.
Okay, what is the answer?
2.2422.
2422, yes. 2.2422. Okay. How to get the critical value for this part? It is F 1 minus alpha divided by 2, degree of freedom 26 minus 1, okay, 26 minus 1. Okay, so we get F 0.975, then we have 25, 25. Do remember, we could not get this value from the table.
Yes.
So what we should do?
1 over.
We use 1 minus F 0.975 and 25, 25. So since this both population, okay, we have the same number of the sample. If not, you have to what? Interchange this. Understand? So I highlight here, indicate you should interchange it if the number of sample is not the same. In this case, it is the same. You change it also be the same.
Yes.
Hence,
0.025 or 975 for the below one.
sorry, yes, 0.025. 0.025. Hence, we use 1 over 2.2422 because this value can be found from the table. Okay, so with this we get 0.0.446. here. Okay, it's fall in the acceptance zone. Okay, acceptance zone. Okay, so what is your conclusion?
Fail to reject.
Yes. Okay, fail to reject. Hence, the conclusion fail to reject. Hence, we have enough evidence to prove that the variability are the same. Okay, can? For this file, question 1 has been discussed last week. Just left 2, 3, and 4. Okay, so I will start the discussion with question 4 first. Don't use T level. Don't use P value. P value I will teach you chapter 5 later. Okay, we use alpha, which is equals to 0.05. Okay, I will start the discussion with question 4. Again, from the question 4, this is related to what? Very straightforward. They are tested on the variability. And they give you 2 types of instrument, A and B. They want to determine, okay, you have the same variability or not. Okay, means that standard deviation or variance. Okay, so they provide you the information, but they do not provide you the sample. The most important we must have is what from here.
Mean.
Yes, mean as well, because if not, you can't determine the sample standard deviation. Are you able to calculate this? Can, right? Using the formula. So this one, you need to do more job. Okay? So you need to calculate the mean, sample mean, then calculate the sample standard deviation. Okay? So, however, they ask you to make the hypothesis regarding the sample, the population standard deviation. They are the same. Okay? You can use the variance, the same. Understand? Population standard deviation. Okay, so to answer question 4, we should use the same method as the previous question. Okay, question 4. We have A, we have B. Okay, we want to know is that same or not in terms of the population standard deviation. Okay, in order to do so, okay, so we collect a sample. For this sample, and A is what? The number of sample is what? 9. Okay, both are 9, right?
Yes.
9. Okay. However, this question is not straightforward. You need to find X bar A first. Okay? You need to find X bar B for sample B. Then you also need to calculate, okay, sample variance. Okay? I will give you this variable. So 0.7456. Okay? This you get 0 variance, sample variance 0.010. here. What is the test that we will use here?
F test.
F-test. Which divided by which one? You have to use 0.0125 divided by 0.0108. So what do you get?
One point one five seven.
1.15. Okay, you get 1.15. You get the F-test ready. Okay, because the alternative is not equal. Not equal, when we compare the critical value, we must know there must have two. One here, one here. So here we take 0.95. Then from here, both sides, of course, this will equal to 0.025. Okay, here will be equal to 0.025. So what is the critical value here? We can obtain from the statistic table. This one is written 0.025. Degree of freedom, 9 minus 1, we get 8 because both are the same. Are you able to find what is this?
No. 4.43333.
You will get 4.433. Okay, what is the critical value here? It is F. That's 0.975 and then 8 and 8. Okay, again, we can calculate it using 1 over F. 0.025. I will exchange this 8 and 8. However, since they are the same, we need to do anything.
0.2256.
So we will get 0.2256. Now we get two critical values. Okay, so now we have to compare the F-test. F-test, okay, somewhere here. This is the F-test. Okay, this is the F-test. Okay. Yeah, fail to reject and highlight first. So our decision is fail to reject non-highlight. Okay. Hence, what is your conclusion? We write now hypothesis. They are the same, huh? Okay, so they are the same. If the variance is the same, of course, the standard deviation must be the same. The objective of this question is to test the calculation standard deviation. The standard is test variance. Okay, if you tested the variance are the same, of course, the standard is the same. Then go to question 3.
Question 3. Good.
Here. So this is the solution for question 4. Okay. So how about question 3?
Variance.
Yeah, about variance. Okay. A soft drink dispensing machine is said to be out of control if the variance now. we are tested on the variance. Now they tell you this statement. Okay? They say that the machine will be out of control if the variance exceeds 1.15. Okay, now they collect a sample of 25 trees. Okay, and then they find out that the variance is 2.03, of course, out of control, but is that at 0.05, okay, level of significance, the entire population also out of control. Has it, okay? This is the solution for question 3. Okay? So, for the population, okay, we want to test on the variance. Is that more than 1.15 or 1 question mark? Okay? This is to say that out of control. We want to test this out of control. So how to test it? We collect a sample with n which is equals to 25. Okay? We get the sample variance is equals to 2.03. If you look at the sample 2.03, it is already exceed 1.11, it is out of control. But instead, this data represents the entire population. We are going to test it. So how to test it? This is single population and we are tested on variance. Okay? So what is the test that we have to use? Okay? Chi-square. Okay? More than 1.15. Okay? Equal 1.15. Okay? This is our objective, out of control. We want to prove if it is out of control. Question mark. Okay? So, the second step, chi-square test. Okay? We use chi-square test. The formula is n minus 1 s squared divided by sigma squared. Okay, you see we have all this information already. We have 25 minus 1, then we have s squared 2.03 divided by, okay, get this value. Of course, it's based on 1.15. Okay, so 1.15. What do you get?
42.365.
42.365. Yeah, 365. Okay, it could be very large, because it's chi-square. Okay, chi-square test. Now, again, we need to compare it with the critical value chi-square. Okay, more than one-sided. Okay, one-sided. Of course, if you only one critical value. So here indicate 0.05. Here indicate 0.95. Critical value chi-square, okay, alpha 0.05. Don't forget we need to have the degree of freedom, which is indicate 25 minus 1, 24. Okay, are you able to get this value from the academic?
36.415.
Yes, 36.415. Now you get the critical value already. So this one, we call this as chi-square C critical. Okay, so the objective is that, okay, the limits for this, and then we compare our chi-square test. Okay, so we get the chi-square test, of course. Okay, Okay, very clear that is fall in the rejection zone. Right? The chi-square type rejection. So we say what? We have to reject what? Null hypothesis. If we reject null hypothesis, we write a conclusion. Alternatively, now we have enough evidence to prove that the variance is greater than 1.15. Of course, we have enough evidence to prove that for the entire population, they are out of control. Okay? Reaction. That is why you have to see how many micromoles per minute variable. Okay, so they are tested on the chemical reaction. Okay, so I will gather this information and then but can you summarize it? What is the objective of this question? And then it's involved Z test, T test, or whatever. Which category? Okay, you see here from here. There are two categories because they are using two different substrate concentration. There are two. Okay. So is there any reason to believe that if we increase in the substrate concentration, will cause an increase in the mean? Okay. Use 0.01 significant. Okay. And assume that the populations to be approximate normal and with equal variance. Why did I mention this? Because this involves they are tested on the mean velocity, mean. The difference between two means. Okay, so the difference between two means from the notes. Now, you remember that 5 different cases. This one, one of it. So that is why they make the assumption. They assume that the population variance are the same. Means that here, either this or this only. Can you look at the sample? So it's Z test or T test?
T test.
So this is the formula. Okay. So we have to use the T test, which includes S here. Okay. So I will write down the information here. will cause the increase of more than 0.5. Okay, so this is the meaning, more than 0.5. Hence, we want to test this is objective. mu1 minus mu2 is that greater than 0.5. This is objective. Okay, so based on this information, I write down first and to help you understand this. Okay, this population 1 indicates the substrate concentration is 2.0 moles per liter. Okay, we write the chemical terms up. This is 1.5 moles per liter. Okay, now then we gather all this information. So from here, okay, 12 gram. So N1 is equals to 12. Okay, X 12 comes. Okay, so X bar 1 is equals to 8.8. Okay, then what else? Because too many information already. What else? We have
Standard deviation.
we have S1, which is equals to sample standard deviation is 1.2.
因为我有一些感
Okay. For the N2, it is equals to 50. X bar 2 is equals to 7.5. Then S2 sample standard deviation is equals to 1.5. Okay, do you understand now? So at alpha, which is equals to 0.01, they want to test if that increase in the substrate concentration will cause the mean velocity more than 0.5. Okay? Alright? So, now the test statistic, based on the information given from this question, we know that we have to use t-test. Okay, t-test because they make the assumption, they assume the population standard deviation are the same. Hence, this belongs to, I show you the equation again. From here, okay, we are using case 4, t-test. Because from the question, okay, they make the assumption the population variance are the same. And then we don't know about any information for the population variance. Hence, case 4 will be used. Okay, case 4. So copy this equation. So we use t-test.
Apa tu sih?
We have x bar 1 minus x bar 2 minus mu1 minus mu2, then divided by sp, then divided divided by square root of 1 over n1 plus 1 over n2. Okay, so what is the formula for SP? Okay, SP can be calculated using this formula, also given. We have n1 minus 1 times s1 squared plus n2 minus 1 times s2 squared, then divided by n1 plus n2 minus 2. Okay, you see we have all these data. Okay, we just need to substitute. Okay, and then we will get, you calculate. What is SP?
1.376. 376.
Yeah, 376.
Ah.
Okay. Alright. Then you see we get this as P already. You can substitute to this T test. Okay. All others value also we already know this value. How about mu1 minus mu2? You see this mu1 minus mu2, okay? It's not always equals to 0. It depends from this question. What is mu1 minus mu2? I have not defined the step one. Okay? So the null hypothesis mu1 minus mu2 is equals to 0. This is alternative hypothesis. Sorry, 0.5. Okay, because this is objective. We want to test if it is more than 0.5 or not. Hence, what is the value that you need to put in here? mu1 minus mu2.
0.
Yeah, 0.5. Understand? Okay? So can you calculate t test now? What is the t test?
One point 501.
Yeah. So 1.5, right?
Yeah, 1.5.
Okay. So 1.5. So how about the t-test? T-test is just like the normal distribution. Okay. And then from the question, we must test more than zero, more than that. More than that means one-sided. Yeah, so this is the t-test. So how we calculate the t-test? We don't need to divide it by 2 since it is one-sided. So the degree of freedom n1 plus n2 minus 2. Okay? So your t-test, what is the alpha here?
0.01.
0.01. So n1 minus n1 plus n2 minus 2 will become
20.
25. Can you find this value? Number? 2.485.
Yeah. Fail to reject.
Fail to reject. Okay, so what is your conclusion? Rewrite now analysis of. Okay, mu1 minus mu2 is equals to 0.5. 0.5. In this case, we don't have enough evidence to prove it is more than 0.5. Okay? Okay. Yeah, so this is I have completed the discussion for all the tutorial questions in 4A. So later, I will start chapter 4B. 4B, I think I will use 2 weeks in our 8 because it is very important. There will be 1 question for final, okay, and also for your assignment as well. So very important for me. Okay, so I will go slow, okay, to help you understand this topic. Okay, so I will see you later after the discussion of the goodness of free test. I will go through the assignment. I already upload the assignment. Okay, so I have changed the value. Okay, everyone should give the different data. Okay, because it's individual assignment now. Yes, it's random parameter. Yes, so each of you should have different set of data. Okay, then okay. So this is the